Welcome to a new advanced Python topic, encapsulation using decorators. Encapsulation is one of the core principles of object-oriented programming. It means bundling data and the methods that operate on that data into a single unit, and, crucially, restricting direct access to some of the object's components. 1. The need for encapsulation. Consider this simple class. The age attribute can be directly modified from outside the class. This poses a problem because there is no built-in control, allowing us to set an invalid state such as a negative age. Encapsulation aims to prevent this direct, uncontrolled access and enforce data validity. Two, getters and setters. Traditionally, in object-oriented programming, encapsulation is achieved using private attributes and public methods called getters and setters. A getter retrieves the attribute's value, and a setter method sets the value, often including validation logic to ensure the value is valid before assignment. 3. The Pythonic way, the property decorator. Python offers a much cleaner, Pythonic way to achieve this using the property decorator. The property decorator allows a method to be accessed like an attribute. This lets us use a getter method without changing the client code from using dot notation. We use a leading underscore, like _age, as a convention to mark an attribute as intended to be private and not directly accessed. To summarize, the property decorator is key to clean encapsulation in Python. Our next lecture 39.02, Setter and Getters. See you there. Welcome back. In the last lecture, we introduced the concept of encapsulation and saw how the @property decorator could create a getter method. Now, we will complete the encapsulation process by adding a setter method, which allows us to control and validate how the attribute is modified. 1. Defining the property. We start by defining the getter method, which is named after the public attribute we want to expose, scorg. We apply the @property decorator to this method. Notice that inside the init method, we initialize the value to the private convention variable _score. Two, implementing the setter method. To enable setting the attribute using dot notation, we define a second method with the exact same name, score. We decorate this method with @score.setter. This ties the setter method to the existing getter. The setter method must accept two arguments, self and the new _score being assigned. Inside, we implement our core encapsulation purpose, validation. We ensure the score is within the valid range of 0 to 100 before updating the private attribute, or we raise an error. Three, testing the encapsulation. When we access student.score to read the value, the getter method is invisibly executed. When we use the assignment operator like student.score equals 95, the setter method is executed, validating the score before assignment. If we try to assign 150, the setter's validation logic catches the invalid value and raises the value error, protecting the object's integrity. To summarize, setters and getters using decorators provide controlled attribute access. Our next lecture 39.03, Delete Decorator. See you there. Welcome back. We have learned the getter and setter methods using property decorators. The final piece of the property puzzle is the deleter. The deleter allows us to intercept and control what happens when a user attempts to delete an attribute using the built-in Python del keyword, providing complete control over the attribute's lifecycle. 1. Review, getter and setter setup. We start with a class containing a property called salary, complete with a getter and a setter for validation. Now, we want to prevent or control what happens when a user calls del employee.salary. If we did not define a deleter, the default behavior would simply remove the attribute. Two, implementing the deleter method. We define a third method, also named salary, and decorate it with @salary.deleter. This method takes only the self argument. Inside this method, we can place any logic we need. For example, we might log the deletion, perform cleanup tasks, or, as shown here, prevent the deletion entirely based on a business rule, like preventing salary deletion if the salary is below 1,000. If the deletion is allowed, we explicitly call del on the private backing attribute _salary. Three, testing deletion control. We create two employees with different salaries. When we call del emp1.salary, the deleter runs, passes the check, and removes the private attribute. However, when we try to delete emp2.salary, the deleter's logic intervenes, prints the error message, and the del command for the private attribute is skipped, meaning the attribute remains intact. To summarize, the deleter provides crucial control over the final state of an attribute. Our next lecture 39.04, Delete Attribute. See you there. Welcome back. In our final encapsulation lecture, we examine the consequences of successfully deleting a controlled attribute using the deleter method. Understanding how Python handles attribute access after deletion is crucial for error prevention and maintaining code stability. 1. Class setup with deleter. We reuse the property structure, focusing on the name attribute. The deleter method's job is straightforward: log the action, and then use the del keyword to remove the private backing attribute _name from the object's dictionary. Two, deleting the attribute. We create an instance and confirm its initial state. When we execute del product.name, the name.deleter method is called. This successfully removes the underlying _name attribute from the product object. Three, consequence, attribute error. The most important result is what happens next. If we try to read product.name again, the getter method is executed. The getter, however, tries to return the value of self._name. Since that attribute was explicitly deleted, Python raises an attribute error, indicating the object no longer possesses the property. You must wrap such access attempts in a try except block if the attribute might have been deleted. To summarize, property decorators, getter, setter, and deleter, give you total control over attribute access, modification, and removal. This concludes our section on encapsulation. Next, we will move on to working with the JSON data format in Python. Our next section is using the JSON module, starting with Lecture 40.01. Introduction. See you there.